Hi everyone, it's Mrs. Olslager again. I was noticing some common errors with yesterday's turn-in problem, so I just wanted to take some time to walk through how to solve this problem to hopefully clarify any issues and make sure we're all on the same track moving forward here, okay? So first thing when you're finding the volume of any figure is to really look at, okay, what is this figure? All right, and that was what I was noticing the common mistake, especially if we start with tent A, okay? Tent A, I had a lot of you assume that it was a rectangular prism, meaning that you saw that it was laying on this rectangle and said, okay, the base is 6 times 6 or 36. Well, the issue there is to be the base has to have a matching top and bottom, and this rectangle does not. What this prism actually is a triangular prism. I have this front triangle with a matching back triangle, and we see that in orange there, okay? And it's just a triangular prism laying down, which I think was what kind of was the trip up factor there. So what's really going on is my base is in fact a triangle. And what we have to look at here is when we talk about the height is the distance between the two bases. Well, the distance between my two orange triangles is 6. Okay, so finding the volume is area of the base, so I use a big B, times the height. Okay, well, for volume, remember my base was a triangle and the height or the distance between the two bases was 6. Finding the area of that triangle is just 1/2 base, which was 6, times 5. I got that from this information here, okay? And then we're going to multiply that by 6 because that's the distance between my two bases. So the final volume for this triangular prism was 90 units cubed. I don't remember if they actually gave you whether it was inches or centimeters, okay? But that was 90. Then we move over here to this hexagonal-based pyramid. Okay, so let's just think about, because it's a pyramid, our formula for volume changes. The only thing that changes is it's a third of a prism. So 1/3 area of the base times the height, or you could write it as base times height, area of the base times the height divided by 3. All right, where I noticed a lot of you had issues was finding the area of the base, okay? And this is a review from chapter 8. Our base is a hexagon, okay? So we have to first figure out the area of this before we can jump to finding the volume. So let's do just that. They give you what we call the diameter of this hexagon, okay? So really this just breaks into 4 and 4. And remember, when we're finding the area of a polygon, it really helps to, especially a regular polygon, right? We have what I call the reference triangle, or those slices of pizza that goes around. So there are 6 of these identical triangles in this hexagon base, all right? In this reference triangle, we know what we'll call the hypotenuse here, okay? To find the area of this triangle, I still need this height and I still need this half base, okay? So proceeding to solve here, I'm sorry if you hear Fallon crying in the background, we have to figure out some angles in order to get these dimensions. All right, so it is a hexagon, right? To find each interior angle, we have 180 times n minus 2 over the number of sides, right? So n's the number of sides. We get that each interior angle here, or maybe you remember this, is 120 degrees, right? So I have 180 times 6 minus 2 over 6, and this simplifies to 120. Sorry, I kind of ran out of the room there. So what we're saying is this angle is 120 degrees, which then splits into half and half. So this angle here is 60. All right, that's sweet. Because it's 60 degrees, it's a special right triangle, right? And I'm given the hypotenuse. So the short across from the 30 is going to be 2. And then the long across from the 60 is going to be 2 square root of 3. That's where a lot of errors happen, was getting that dimensions of that reference triangle. Now that I have that, I can find the area of this triangle. Okay, that area of the triangle is going to be the base, and I'm just using the half base. This whole base would be 4, but since I have the half base, I have my half base times the height. So the area of one of those triangles is 4 square root of 3. Okay, well, there's 6 of them, so I'm gonna multiply by 6. So my total area of this hexagon base is 24 square root of 3. So this is my big B. This is the area of the base of the hexagonal base pyramid. Now I can go ahead and find the volume. The volume is going to be 1/3 the area of the total base, which was 24 square root of 3, review from chapter 8. And then my height, nice, they gave us the height, I didn't draw it in the picture, but the height of this pyramid was also 6. Okay, so this is 6 here. And so then simplifying, I can do 24 times 6 and multiply by 1/3 or divide by 3 to get a volume of 48 square root of 3. And then finally, we could turn this into approximate form to interpret whether 90 is bigger than 48 square root of 3, and tent A has the larger volume. Okay, so hopefully this helps you with your practice from yesterday. Definitely recognizing that this is a triangular based prism was a tough getting started. And then over here, review from chapter 8, finding the area of a regular polygon. So keep the questions coming, take a screenshot of this. Remember, it's all about engaging and practicing. So go back, try it again, resubmit. I look forward to hearing you guys. Have a great rest of your day, Saints.